China is building floating nuclear power plants, nuclear reactors mounted on ships or offshore platforms, designed to be towed anywhere in the world and plugged into a power grid, powering remote islands and offshore oil rigs. Let's see how this all started. In 2019, Russia did something no country had ever done before. They launched the world's very first operational floating nuclear power plant, called the Academic Lomonosov. It is a large barge about the length of 1.5 football fields carrying 2 nuclear reactors. On its deck, Russia towed it 5,000 miles across the Arctic Ocean to a remote town called Pevek, an isolated place, no pipeline or power grid, and it worked. The Academic Lomonosov now powers thousands of homes and industrial operations in one of the coldest, most remote places on Earth. China started developing its own floating nuclear program back in the early 2010s, nearly a decade before Russia even launched theirs. The question was, what exactly did China plan to do with it? Ling Long 1, China's floating nuclear reactor. Its technical designation is the ACP-100S, developed by the CNNC, or China National Nuclear Corporation. An engineering masterpiece. Traditional nuclear plants are enormous, take decades to build, cost tens of billions of dollars, require massive cooling systems, huge containment structures, and a full city's worth of infrastructure around them. The Ling Long 1 is the opposite of all that. It's a small modular reactor, compact enough to be manufactured in a factory, shipped in sections, and assembled on a floating platform at sea. It produces 100 megawatts of electrical power, enough to supply a city of roughly 100,000 people, or power an entire chain of remote military or industrial installations. Traditional nuclear plants are like custom-built skyscrapers, each one unique, expensive, and planted permanently in one spot. While the Ling Long 1 is more like a powerful, movable generator that happens to run on nuclear energy. You build it, float it, tow it, wherever you need it. With its modular structure, China can create a lot of them, not just one. The South China Sea. This is one of the most contested stretches of water on the planet. Roughly $3.5 trillion worth of trade passes through it every single year. 6 countries claim overlapping pieces of it: China, Vietnam, the Philippines, Malaysia, Brunei, and Taiwan. And for the last decade, China has been doing something extraordinary. It has been building artificial islands, literally piling sand and rock onto reefs and shoals until they become land masses large enough to build runways, ports, radar stations, and military facilities on. The problem? These islands sit far from mainland China. They're remote, and keeping them operational requires enormous amounts of energy, keeping lights on, radar running, personnel housed. Right now, China ships fuel to these islands by boat, diesel generators. Expensive, logistically difficult, and vulnerable. But a floating nuclear power plant changes everything. Park a floating reactor 10 miles offshore, then run a submarine cable to the island. Suddenly, you have unlimited, stable, independent power with no supply chain, no fuel tankers, no vulnerability. You've just made a remote military outpost self-sufficient. That is precisely what Admiral John Aquilino, the former commander of the US Indo-Pacific Command, warned the world about. He and the US State Department explicitly raised alarms that China's floating nuclear program could be used to assert unlawful territorial claims in the South China Sea. Under international maritime law, there's a concept called an exclusive economic zone, a 200 nautical mile radius around a country's coastline, where that nation has rights to resources. Artificial islands built on contested reefs don't automatically grant those rights. The legal arguments are murky, contested, and ongoing. But a floating nuclear plant doesn't care about maritime law. It just provides power. Power changes what's possible on those islands permanently. Now here's the question that keeps nuclear scientists up at night. What happens if one of these floating reactors gets damaged? In 2011, a tsunami hit Japan's Fukushima Daiichi nuclear plant. The cooling systems failed, reactors melted down, hundreds of thousands of people were evacuated. More than 13 years later, the cleanup is still ongoing and cost over $200 billion. On land, you can contain a nuclear disaster, seal it off, build walls around it, and block the groundwater. Now imagine the same scenario, but the reactor is floating in the ocean. There's no groundwater containment, no geographic boundary. You have an open ocean. Currents, marine ecosystems, fishing waters that feed hundreds of millions of people across Southeast Asia, Japan, South Korea, and the Pacific. A damaged floating reactor in the South China Sea wouldn't just be a regional crisis. Given ocean current patterns, it could become a global environmental catastrophe, and scientists aren't just speculating about this. China's own nuclear regulatory authorities have reportedly flagged internal concerns about the safety and feasibility of deploying these reactors in open marine environments where typhoons, military conflict, or mechanical failure are all real variables. The South China Sea, specifically, is one of the world's most typhoon-prone regions. Typhoon season brings storms powerful enough to batter offshore oil platforms. What happens to a floating nuclear reactor in a Category 4 typhoon? CNNC insists the ACP-100S design has passive safety systems. It can cool itself down, even without external power or human intervention. The design is built to handle extreme marine conditions, but there's a gap between designed to handle and proven to handle, and today, no floating reactor of this type has ever faced a real-world extreme weather event. Russia's academic Lomonosov operates in the Arctic brutally cold. Yes, but not a typhoon country. China's reactors would be in a different league of environmental challenges. The floating nuclear story is about the future of energy globally, not about China or the military. Right now, there are 733 million people on this planet with no access to electricity. Most of them live in remote coastal regions, island nations, or areas where building traditional power infrastructure is nearly impossible, either because the terrain makes it too difficult or because the economics simply don't work. A floating nuclear reactor could theoretically reach all of them. Build it at a central facility, tow it to wherever power is needed, plug it into a local grid, and solve an energy crisis without laying a single mile of power line through dense jungle or across mountain ranges. That's revolutionary. If it works safely, and if it's managed responsibly, floating nuclear power could be one of the most important energy innovations of the 21st century. China is not the only one who sees this. The United States, South Korea, and several European nations have their own small modular reactor programs in development. Every major power on the planet is now chasing the same thing: smaller, faster, movable nuclear energy. Nobody is slowing down. But China has a specific advantage. It has the South China Sea, a ready-made strategic theater, already built artificial islands that need power, domestic nuclear industry that moves faster than any Western equivalent, and a government that doesn't require public hearings, environmental impact debates, or multi-decade approval processes to get things done. When China decides to move on something, it moves. And on this one, its engineers have been quietly working since the early 2010s. That's over a decade of research, design, and testing. The world needs more energy. Billions of people still don't have reliable power. And floating nuclear reactors, if done right, could genuinely change that. Reach the unreachable. Power the places no cable or pipeline ever could. China saw that opportunity early. Over a decade of quiet research, a prototype already under construction. Deployment planned before the end of this decade. The technology is real. The ambition is real. The only question left is whether the world is ready for it. And if you think this is ambitious, China is also building something even more radical on land. A nuclear reactor that runs on thorium, one that almost never needs to shut down. We broke that story down completely. It's right here. China's world-first thorium reactor that never shuts down.